to this week's Tech Excellence session. My name is Ollie, and as you probably already know by now, our vision is to raise the bar of technical excellence across the world. Who are we? Well, we are Valentina, who is our founder and organizer of Tech Excellence, and Daniel and Alina and me. We are both co-organizers and also hosts. We already had a great couple of speakers in the past, and we will also continue to have lots of great speakers in the future. You can follow us on all the shown media, social media like Meetup, YouTube, LinkedIn. It's not Twitter anymore, it's X, GitHub, and also Discord. Our sponsor is Optivem, and our partner is QE Unit. And now I am really happy to be joined by Nik Sumeiko. Nik is a software engineer and an architect with over 17 years of professional experience. He currently works at payment system at George, the digital banking solution of Erste Group, where he actually practices pair programming and mob programming and uses these practices on a daily basis, which is very rare and which we are really happy that this actually exists. Beyond programming, Nik also trains web developers in-house at enterprise companies all over the world and also on LinkedIn. And today, I'm really happy that he will show us how we can actually ship React app with zero bug policy using test-driven development. And this is also something that I personally always struggle with. But before I hand over the mic, I want to remind the audience that you are very much encouraged to write down any comment, observation, or question you have in the comment section down below. And after Nik's talk, we will have the time to discuss them all together. But now I actually hand over the mic to Nik. So Nik, the stage is yours.
Hello, everybody. Today I want to make a deep dive into building React app using test-driven development and introduce you to zero bugs policy and how we build a system to maintain the quality of the software at very high level in the digital banking solution that I work on. All right, so first, there are many product development problems, but let me list first significant economic ones that I think our job as software developers can impact positively or can impact negatively. For example, shipping new features versus fixing bugs is a common problem in our industry. When we don't have a process that enables us to ship with quality, then we will be always in the season, where whenever we deliver a new feature, some already existing one breaks, and we have to stop moving on until we fix bugs. Or another problem is when we don't have a system to design a simple code that is easy to change, for example. At some point, we will go and ship the next feature much longer. It will take much more time. We put in another hack in favor of moving quicker now, but it's a dead end. After hack, and some software design turns unmaintainable. Okay, another problem is when we want to work on a legacy code full of hacks, people get demotivated, especially when it's under pressure. People can lose motivation when the system is hard to extend, hard to enhance with the new features, new business requirements. Therefore, skilled talent retention is low, becomes low. Onboarding new hires takes time. And it's actually very expensive for the company to have people leaving the project after 6 years and onboarding new people again. Shipping software is also a responsibility. For example, in my context, I work on digital banking app. And how would you feel if one day when opening your banking app, you see a screwed up account balance, or it's negative by mistake because the development team shipped the code with a bug. How would you feel? Probably you will lose trust in this bank, won't you? Losing trust is losing a customer. Therefore, it's a high responsibility of what we ship, what we work on every day, and to deliver it to the people. I think we could tackle these kind of problems by having a system that enables to ship software that works. A system that I call test-driven development. All right, here is a small real-life project we will be building today. Let's learn business requirements a bit. So the idea is to enable the user to explore the international bank account number details when the bank account number is a valid one, or provide feedback to the customer when the IBAN is invalid. Because our team is doing behavior-driven development, you can see that requirements here are nailed down in a very comfortable way. So first acceptance criteria would be to create a page with a form with IBAN input and a submit button, so we could validate the IBAN. Then the IBAN that customer entered into the input field, we are supposed to send to the API. And then based on what API returns, there is some criteria how to display different validation results in the list here. Otherwise, if API throws an error, we're supposed to display some kind of error message, as is seen here. At the right of the screen, I have API specification, also available within this task. And the idea will be to call get method for validate endpoint within our API by providing the IBAN that the customer have been added into an input field, and the response, the shape of the response will look like this. The API, if the IBAN is valid, will provide back the IBAN itself, and some flags that will help us to actually draw these results in the middle of the page. Plus, it also will provide you a trust score for a particular bank. Of course, we have some test data to validate whether everything works correctly or not. So first, before we start actually the process of test-driven development, I want to introduce you to the initial project structure. And here what we have is a React project built with Vite. I'm using TypeScript here. Beyond that, I'm having an app which outputs at the moment just hello world, nothing much, we will build. On top of that, I have some internal design systems, a system with already prepared set of React components that I can use. They are using Tailwind. Here you see probably familiar syntax of class names that Tailwind outputs. It will help us to compose actually our application. If we look at package.json, what is important, here are some scripts to start my app. But what I want to put your attention on, that we have a command to run unit tests. We will be using vtest for that. There is a command to run integration test. For that, we will be using Cypress components testing. That's a tool that enables to do UI testing. And we have a command to run test end-to-end. And for that, we will be using another approach with Cypress, not components testing, but end-to-end testing. They have different approaches I will show you during the development. So already 3 types of tests that we will employ today. Will be fun. Okay, back to my slides. Now, when we look at these business criteria or business requirements described in this project, in this task, could we try to think what user journeys could we extract from these business requirements? The first journey I can detect is when I provide an IBAN to the software, I see validation details displayed, this thing. I consider it's a critical user journey. Why? Because if it doesn't work, the purpose of our app is lost. The user doesn't have any reason to use our app if this main feature, main behavior, or journey doesn't work. The second journey I see here is about when the IBAN that I, as a customer, provided is not valid, and therefore is supposed to see an error in some sort. Here, the UI describing it. And I consider this is a minor user journey to display that error, because look, if we fail to deliver the error when I entered an invalid IBAN into the input field, I, as a customer, will recognize like, okay, maybe something wrong, maybe this IBAN is not valid, and therefore I don't see neither results, neither the error message. So this is my decision that I take that, okay, this second journey is more minor, more like an edge case. But the first journey to output the results is actually the critical one. Important is to identify these journeys when you look at your business requirements, because they will help you to think what kind of test to employ. And here I have a simple diagram. Whenever I identify user journey, I try to decide what test fits best. The user journey that is critical, I think, shall work no matter what. The best test from perspective of confidence would be an end-to-end test, because it replicates the user environment almost one-to-one. The testing robot would open our app in the browser just like user would do, and go through the steps the user, the customer, goes when completing a certain journey. For the minor user journey, I could employ an integration test. I will explain this and demonstrate it a bit later. But I think it fits best because it's 10 times faster than end-to-end test. It won't communicate to any API, nothing. And therefore, I'm fine to validate like edge cases using that kind of test. But only edge cases that could be represented in a user journey. And last thing, if I see that in my application development, there is a business logic involved that is not directly representing a user journey, but only accompany it, then I will pick a unit test, the fastest test that we have available. All right. The first thing what I try to do is to describe our critical user journey in a form of a test. And this is a Gherkin syntaxes. You probably are familiar with these given, when, then keywords. So I'm trying to, in a human English language, explain the journey that I want to develop. Given I open a validation page, when I provide an IBAN, then I see validation details. This test, even it's not a test at the moment, it's just an English written scenario. It actually will serve us as a high-level documentation for the whole team, not only for technical people. For example, when onboarding new developers or new people in the team, could be business analysts, designers, and so, giving them to go through this kind of high-level test will create an impression very fast how the software actually works. I call this type of test an acceptance test. And here is implementation behind each step. So I guide in the first step, when I open a validation page, I guide the testing robot to visit a certain URL in my app. Then I guide the robot to find an IBAN input field by an HTML element that has particular attribute, in this case, data test. and type in this field an IBAN, and then hit enter. Afterwards, I guide the testing robot to actually verify whether certain strings are displayed on my page in my app. This implementation is done using Cypress. Cypress is a tool that helps to write this kind of tests. Now, if your environment or your infra doesn't allow to spin the API or backend to run end-to-end tests, it's fine. We could run end-to mock tests. So instead of going to real API, in the step, we can mock a particular API endpoint and make sure that when robot opens the page, and there will be a case when our application will communicate with the network, the request will be stopped and the stop will be returned. Okay, let's run this test now. Of course, it fails. I just put a test up front, but no production code was written. That's a red test. What is important at this stage is that we clearly understood while writing this high-level end-to-end test what's the expected software behavior, what is the user journey we have to implement. It's time to work on implementation now. So I go to my app component, the highest component that outputs hello world, and I replace that line with rendering validation page, a component in React that doesn't yet exist. That's fine. Then I create that component that I just put in my app, validation page TypeScript file, and using my internal design system, I try to compose a view. I try to put some title in there, already putting some form with an input field, which is my IBAN input field, and the submit button. Plus, I also fake the display of our validation results at the moment like this. And we can already see, even in the browser, that the output will be like this because of my internal design system. Okay, now the next step, what I do, and it's, I believe, familiar for many React developers, is to introduce an internal state to make the form controlled. Plus, I add onChange handler to my IBAN input. Whenever the customer types the value inside the input field, I want to store that value into my internal state of the component using useStateHook from React. In the next stage, I think already, all right, so my form have to be submitted. And when the form is submitted, I actually have to do an API request. I'm aware of that because of business requirement and API specification I have here at the right. And first thing what I do, I type a validation response. According to this response table in my API specification, I identify IBAN, flags, and trust score of the bank. And at the left side, I also think, okay, but I will make this API request, but where are going to store the response? And in React application, you use some kind of state management. In my case here, I'm using React Query. It's a popular state management these days. And I'm importing this use query hook from React Query by feeding a validation response type from TypeScript in that, so React Query knows about this. Plus, I introduced here a submit handler. So whenever the form is submitted through the submit button or by hitting an enter key, I want to store the IBAN at that moment in some internal state and feed this IBAN to my query. But to make sure that the query can actually store the response, we need to make an API request. In terminology of React Query, the query needs a function that will do an API request. And look, Currently, we were composing our view, just putting some code executed in a sequence. We employed some state, we rendered some HTML and React components there. But now we come to this moment where we need business logic. So what is business logic? I think it's wise to review. Developers building React apps often refer to the term business logic, and most of the time being uncertain what it actually is. In reality, it's that simple. Business logic are if statements, logical control structures, for example, if, else, or switch, loops like while, for each, for in, for off, data transformations, data extractions, retrieval of the data from some place, and side effects, for example, API calls. I also consider the business logic. So business logic is purely technical term invented by programmers. Don't mess up it with domain logic. That's another thing. All right, we are back to our component. And now I pasted here at the right side a screenshot from React query documentation, and they visualize how to employ global fetch function that browsers provide to fetch some data, and then these data will be automatically stored in my React application store that React query will do. So our idea is to build such functions like in this example. But what shape it would be? If in their case they use this to-do ID, but in our case we will be IBAN, and I think the shape of that function shall be something like this. It's a function in our case that will create another function, so a factory that returns another async function, similar like here at the end. But we need another one, a wrapper one, because we need within a closure, JavaScript closure, to store the IBAN and then access it here when we will be doing an API request. So I picture it like this, but that's just my imagination. So what we start with whenever we face a business logic demand while composing our React, we start with a unit test. And here I'm created a validation API service test. And in this test, I'm trying to assert a successful response for provided IBAN. I start writing tests from the assertion because it gives me clarity on what behavior shall the function do. In this case, some result shall be equal to the output that looks like a shape of my API. Then I continue with an action. And here I'm trying to think, okay, how I build this kind of shape that I put there in my picture. And I think we need a function which we will, let's call, create IBAN validation API adapter. That's a function like this that will return retrieve an IBAN as an argument and will return back another function. In this case, like I picture it as an adapter name. And this function will be asynchronous, and it's on its own will finally do these global fetches executions to communicate with an API. And when I call this function, I expect to get a result, finally, the API response, which I assert there. All right, and the last thing that I do when I write unit tests, I do arrangement. So you have noticed that I wrote a test backward, like assert, act, arrange, AAA pattern, in favor of clarity. This helps you with clarity. Okay, so we have this test, and now we can think more. But okay, this test doesn't do any API request, nothing. So this is a trick now. Instead of mocking any global fetch function, I don't want to go neither to the network, because imagine how slow will be unit test if they go to the network. I want to somehow fake the global fetch function. But I also want to make sure that my test is not coupled to the inner detail. My test is not aware that there is a fetch used. So here is what I come up with. I create a fake using vtest tooling that could output a similar response that fetch can do. It's like status OK and some JSON method that will return you here a fake API response. Then I enhanced my function, which yet doesn't exist, with a second parameter, which will be options, where I pass request property as my fake, as my spy. And then at the end, I want also to assert some details that actually my fake that I created here will be called with certain API endpoint. And since we are supporting REST JSON responses, we have to provide a header to get back a JSON response. All right, this is just a test, no production code in place. Now let's work on the production code to make this test pass, because this test will fail. We don't have any implementation yet, neither this function is created. So I'm creating that function itself with a signature that I already identified in my test here. So it's a function that returns another function. And now I will start vtest in a watch mode. And obviously my vtest unit test will fail dramatically because, well, there is just a comment, no implementation. Okay, so we continue by trying to figure out the minimum amount of code in favor to make this test pass. So we wrote here this thing. We created a variable called response and called the request, which comes from our options. If it's not provided, it will be using some fetch, and it does the API request. But in the test, it actually won't do API request because I faked it. I pass here the fake as a request. So fetch default value won't be taken in place. In production, it might be taken in place instead of any fakes. So we continue and we rerun our vtest, and it passes now because the implementation does exactly what the test expects it to do. All right, so we continue with the next small test. That test will be to assert a situation where the API actually fails. And for that, we try to create a fake of our fetch mechanisms that interacts with the network. And OK status is false here, and the JSON function returns some string, some error, let's say, that API could theoretically provide. The arrangement here stays the same. So the mock is in place, or in this case, it's mock. In another case, it's fake. And here is an assertion that vtest allows you. When we call that adapter, it should be rejected. So it shall throw an error like this. We run our test. Of course, it passes because we don't have this logic implemented. And we continue now with implementation. And here we added some more details of the implementation, some if condition, if status is OK. Then we return the resolution of JSON function. Otherwise, we throw the resolution of JSON function. And we rerun the test, and the test now fails because it now considered when status is OK, false. Then, well, it throws as a per implementation, and here we assert that the error is actually thrown. When having green tests, we are now safe to do some refactoring, if necessary. And here I'm introducing an intermediate variable to resolve API response in advance. Okay, so it's a small refactoring step. When I rerun my tests are green again, so I'm confident that I didn't break expected small behavior of the unit. That's quite good. You might not realize, but actually deciding to develop the API adapter aside from the React code impacts our application design and architecture. The adapter we developed is now an isolated functional layer. and the test played a significant role to have it isolated. All right, so what we actually were doing now is we were writing a failing unit test, small one. Then I tried to come up with some minimum amount of code to make it pass. Then I was repeating with the next failing test, or I did a small refactoring if it was necessary, but only when my tests were green. So I was confident that changes that I do by refactoring doesn't break the behavior. We iterated through this circle. This circle is called test-driven development circle, where we always prepare a test up front, then try to make it pass, then fine-tune our implementation. Iteration after iteration, and we end up with isolated API adapter ready. And it's ready to be consumed. Back to my validation page component, my React code. I import my API adapter directly into my React component and feed it to the React query function. Now it's very similar to how React query docs shows working with fetch. And since I'm using React query, I have to wrap my validation page or the high order component that we have in application with query provider. In favor, React query can manage the global state of my React app. So I'm doing this. Now, while composing the view, we arrived at the point that we need more business logic. We need an if condition. In React's context here at the bottom, it will be conditional rendering. The first question I ask myself again, how do I test this? And you already guessed that I will put this aside and build this using unit test, the business logic. So I put some unit test that I want to return the whole view model, or in other words, the object that my view or React component needs to render properly. The bigger the unit, the better. So I decided to create one function that will process the data from API and do stuff, and output an object that is used only by the view and necessary by the view. So it's a kind of factory that will produce a view model. This is what I want to build. So I start with an assertion again. I expect that some result, we don't know yet what, will have a property is validation available to be false when, and we call this availability, when validation, the response from the API, is actually not available. We continue with an action, and we picture that there will be some create IBAN validation view model function. It doesn't exist yet. I'm just trying to draft it in the test, draft my design and naming in the test. And then we end up with a arrangement where we arrange that input validation, that's response from API, is undefined. Very simple test that asserts just one property from my pictured view model, this result object. And I continue, I introduce the validation view model service, and now finally declare the function with its signature as per my test. There will be some validation, that's response from the API. And to make this test pass, I just put false. That's it. I run my v-test and the test passes. All good. Then I continue with the next small step forward and write another red test. When availability, like I want to assert that this is validation available, availability is true, then validation, when the data from API provides some results. For example, it provides IBAN and flags as per interface of the response from API. The same action. And now I rerun the test. The test obviously fails because the production code always returns false. Okay. So how to make it pass? Actually, both tests pass. We need to introduce some business logic, a Boolean that will convert our validation response into true or false. And we rerun the test pass, all good. And I think it's now the step that we can integrate this small condition already in our view. So look, I added this line where I created a model variable by calling that function that we just designed and feeding the data from React query, the data that actually API adapter provides and the React query allocates within our React app state into my factory method here. And I allowed myself to also put here an if condition, or not if condition, conditional rendering only renders this list of items with fake data at the moment when this is validation available is presented. Okay, let's run our end-to-end test again. And we are running the test. It's already in a better state, but it doesn't pass still because this data is still fake. We expect something else here. We expect the test robot expect that there will be some valid IBAN message in place. That was programmed when I was implementing the steps behind Gherkin scenarios, actually. Okay, so we continue with the next thing. And the next thing will be trying to replace that fake XYZ results of my validation to a real ones. And that's, again, a business logic I put here at the right from my task, how the things shall do, when which validation result shall output based on which criteria. And we will try now to write a test for these criteria, actually. So we start with the first test where we picture that our result, so actually view model, will contain some validation results property, which will be an array, an empty array, when the response from the API is not available. Action is the same. And we will run our v-test. Since I'm running it in watch mode, it will constantly help me to see where I am. And of course, it fails because we don't even have this property introduced in our implementation. So we introduce that, validation results with empty array. And guess what? Our test will immediately pass. Well, because here is an empty array, and this is what we expect. Okay, we continue with a small next test, and this will be now looking at the API specification and these details, criteria when certain validation results shall be displayed and when not. And what we do is to expect that validation result is an array with a valid IBAN string when validation is just available. And here I'm trying to fake or stub a response from API with IBAN and no flags, and then call my action. When I run my unit test again, the second test will fail because the current production implementation now returns only an empty array. So I need to put a minimum amount of code to make this test pass. So I put a ternary operator here. When validation response is actually available, I just put an array with valid IBAN just to make sure this test pass. Otherwise, I put an empty array. So I rerun the test passes, so all good. We are continuing in baby steps for the further requirement based on these criteria here. And now we want that validation results array to contain trusted bank. In case, as per criteria here, the trust score is over 7. So we stop our API response here with the trust score 8, feed it to our factory that builds a view model as a validation variable, and rerun the test, and the test fails. Okay, the test failed, that's fine. But look, with this ternary in place, I cannot extend it with a new criteria of putting trusted bank into this array. So I do small refactoring step at this stage. And here is what I do. I just introduced a result, empty array here. Then I put an if condition, if validation is just a variable. Then I push to this array valid IBAN. I run my tests, and 2 first tests, they pass. The last one still not, because there is nothing about trusted bank implemented. So okay, after this refactoring, which was also safe, I continue to do the implementation. And now another if condition, another business logic, where I see, okay, if trust score actually arrived from API and it's over 7, then I push to my results array trusted bank. Okay, I run my tests. They are now again green. That's good. Feels like you want to refactor this multi-line if condition and abstract magic numbers in there, right? I would do refactor too. I feel again totally safe because my tests are running in a watch mode. They are all green. So I could do some refactoring by maybe abstracting away this big if condition. So in baby steps, we will continue implementing further logic as per this criteria here in my task to implement the whole view model, the whole validation results array, so it satisfies these criteria here in baby steps as I demonstrated. And at the end, I fast forward a bit to do not show you every small baby step. I end up with this kind of code, production code, that here I abstracted away that big if condition into has trusted bank private function somewhere above this. And I implemented the rest of the criteria in the same manner. Red test implementation, if necessary, refactor. Red test implementation, if necessary, refactor. Many people are not aware that vtest provides you a coverage report, very detailed. So you could run your test and it will output this kind of coverage where you could explicitly see whether each line was properly asserted and executed in your unit tests. In my case, I did a good job. I have 100% coverage. And actually, this is what we have to strive for when we build unit tests. All right, we are ready to integrate validation results, what we built in our view model, into our React code. So we are back to our validation page React component. And here at the bottom, we still see this fake data. And now what I do, I just replace this fake data with the model.validation results, which I take from that model that is generated by this factory function. So we took another decision, actually, when we were test driving our view model to build it aside from React, and it impacted the design. We didn't overcrowded our React component, which is considered to be a view layer. For example, when at some point we move business logic into the backend, the business logic is already isolated. I know some people from LinkedIn developers community are using BFF. It's backend from frontend. It's a kind of intermediate API that could do the business logic and feed to the React application already prepared view models. So in my case, I don't have this BFF. Therefore, I put the business logic and design it using unit test, but it's isolated and ready to be ported anytime we want it. All right, whenever a new business requirement comes to enhance this, let's say, feature with validation, I will also probably modify only my view model code, but won't touch a React component. I will maybe introduce a new criteria of validation. So this isolation will help you actually to maintain this code further because you won't have to touch the React component. And it feels like a single responsibility, you know? The view has its own responsibility to deliver the view model to the view layer. The view layer has a responsibility to render some HTML, React code. And that's the case. And I think we are ready actually to run our end-to-end test. So I'm running the end-to-end test again. And now I see it's passed because we replaced that fake data with a unit we developed with our view model. And software behaves as we expected. The journey is now covered with a good test, end-to-end test. So what we actually did is we introduced another circle in our development flow. We wrote some failing acceptance test that was our end-to-end test. And we started composing React component, React view. Whenever we faced a demand for business logic that was an API adapter and view model, we immediately turned to the inner circle here, a small one, where we build and design a particular unit using unit tests. Red test, green, refactor if necessary, repeat. By repeating multiple times, we end up with good isolated state of our business logic. And then we try to rerun our acceptance test, a big circle, and it at the end passed. This kind of test-driven development, it's called outside-in test-driven development, also called acceptance test-driven development, and there are multiple styles of test-driven development, and this one explicitly is called Detroit School. All right, now I think it's time to implement the second business requirement which we have is to display this error message in case API fails. And to do that, since we decided at the beginning that this is not critical user journey, but rather an edge case, I decided to pick an integration test for that. And the integration test in Cypress looks like this. It's similar to end-to-end test, but there is no Gherkin involved. So what I'm doing is I'm asserting that this IBAN is invalid. That's an error message, should be visible on the screen. So I'm guiding the testing robot to make sure that it is there. And also I'm guiding the testing robot to type certain IBAN, invalid one, inside the IBAN input field and hit the submit button. And there, I somehow don't want again that my test interact with the network, because this will be then slow test. This is not an end-to-end test. This I need to be very fast. Therefore, one way is to fake API request, actually. And this could be done in React's context using inversion of control, okay? And for that, I introducing some context provider. That's a simple tooling that I have in my repo, you could see afterwards, that helps us to achieve a type-safe React context API, okay? So the syntax is like this. I define for that case an interfaces. Here we can see familiar already things. This is API adapter. That's a function that returns you validation response asynchronously. And that was a factory that we built, designed with unit tests, which supports IBAN as a parameter and outputs API adapter. Now I configure my React context using these typings in favor to make sure that in TypeScript I have type-safe context. And I create also a public use validation adapter factory method that takes a value from React context API and just returns it back. And now I can employ this thing, this additional tooling that I had, by creating a fake API adapter that will match this type that I have here and the one that we designed with unit test. And in this test particular, I wanted my API adapter actually throws an error. So I pass this API adapter in a form of factory function, similar to this one. Here I omit IBAN parameter because it's not necessary for this certain test here. And I created this fake API adapter. But okay, test is test. And of course, if we run this test, it will fail because we don't have the dependency that we pass through this test, like this fake implementation of API adapter. We don't use it anywhere. So the test failed with some error probably because something is not used. And now look what I'm doing. I'm back to our validation page component. And remember, we here imported directly our API adapter. So we tightly coupled our API adapter to the React component. I don't want this anymore in favor to have a test that works and is resilient. So I remove the tight coupling and I import this hook from my context thing, and its hook just provides me an adapter, and I call it adapter. Now what happened? Actually, now we made sure that dependency of the adapter is inverted, and the validation page is not aware about the implementation of the adapter. It's only aware of the interface of the adapter. Okay, this is dependency inversion principle here in place. We are loosely coupled now between API adapter and the React component. All right, since we had put some fake in real production code, we don't have to put a fake of our adapter like in test we did, but we have to wrap like in test with this context provider, which is type safe, and feed a real implementation. Here we import a real implementation of the adapter and feed it to there, so it's stored in React's context. And now every consumer of React context, which will be consumed from there, will actually receive this implementation. But as you see, this code is very similar to our test, and therefore in test we faked it and made sure that API adapter is not real and it doesn't go to API at the end. Okay, so this was an integration test, and beyond that, I continue working because I need to make sure that the error from the API is actually delivered to my React component. And I take the error from React query because the React query provides it when query function actually throws. And in my test, I made it throw. And now I picture that this could be a second argument in my view model. Even TypeScript will fail here because my current signature doesn't allow this. Plus, I employ some prop from form field design system, in my case, and feed the model.validation error inside, consuming that there will be some validation error. And it's not yet defined. I just define it here while composing, but it's not defined. And TypeScript will throw an error here too. I'm using property which is unknown yet. So business logic, again, we enhance or extend our view model a bit. And here we pass inside the view model function that generates the view model an error, like I just put in the composition, and expect that IBAN is invalid. So a message is received. And when I run the test is failed because there is no second argument in the signature. So we go to the implementation here and enhance the implementation with a second parameter. And to make this test pass, we introduce a validation error variable just by hard coding here the output that we want to see and put it there and there whenever we return from this function. And of course, this test will pass, yeah. But we don't want that it always outputs this error. We want to this error is outputted only when API actually fails and the error is provided here. We don't care about the error type at that moment, only that it is error or no error. And therefore, we create a small unit test again, enhancing our model by putting the error, which is undefined, inside as a second parameter. Expect that the validation error will be undefined here. The test immediately fails because at the moment, validation error always comes as a string. So we put some business logic, in this case, ternary operator. When error is available, then this IBAN becomes invalid. This string is outputted like this, otherwise undefined. Our test fails, and actually our test passes, and actually we are ready to try to run our integration test already. Okay, you could also refactor these as a safe state when everything is green. In this case, we can abstract, for example, retrieving a validation error into some private function. Okay. And now I think, yeah, we arrange everything for our integration test to pass. This is an integration test where the similar code is to production, but instead of real implementation, we put this fake that throws an error. And let's try to run our integration test. It's similar to end-to-end test, but it's much faster. And here we see the output visually that it passes now because we implemented the logic for it to pass. That's awesome. And look what, we now introduced some kind of dependency injection or dependency inversion here, where we invert the dependency of API adapter and then consume it in our production code. This allows us to fake it in the test and feed a real implementation of adapter in production code. We had dozens of discussions with my team about this. And also I discussed this with folks on LinkedIn about this inverting of API adapter dependency, whether it's really worth it to have a loose coupling here between these two functional layers. And you know, within our team, we came up to the conclusion that that's an overhead. I just shown you an overhead, I think. Especially because in our case, let's say we have some pages that consumes around 6 API endpoints. So in my integration tests, I would have a lot of fakes for different API endpoints here. So we decided that, okay, low coupling has its benefits, but being aware of what API is used for a particular page gives us more documentation, gives us more information, and gives us more value. Therefore, we dropped faking and dependency inversion here and introduced just mocking. Cypress allows this CI intercept method to mock a certain API request and make sure that the network is not reached, but the step or how we want the request to respond actually responds. So we cut it short like this instead of overhead with dependency inversion. Okay, I will rerun high-order tests, end-to-end tests in case we broke something, but it seems we didn't, and you see it run and execute it and asserted that everything is displayed correctly. Our initial user journey, just to make sure everything works and it's green. I also run all the unit tests and they are green too. This is good, but we develop them like in baby steps. They of course are green. We can also at this stage can try to play with our React app by hand now. So do a kind of manual test if we want. Altogether, we built quite a solid safety net. And here I try to visualize this safety net that we built using a testing pyramid. The first layer of testing is like manual explanatory test. That's very accurate, but it's the most expensive. It requires human to do clicking on your app and validating the things, especially in enterprise-grade React applications where we build a lot of features and our application is huge. Like manual testing is a big investment. Therefore, the second test, which is that gives super confident, is end-to-end or end-to-mock test. Normally, we employ it to test critical user journeys. It's slow because it boots the whole browser and try to replicate the user environment, the actual environment, one-to-one. So we have to be careful which tests we put in there and which not. The next layer is integration testing. We are using Cypress components testing by asserting a journeys happening on a single page. And these are edge case journeys, minor user journeys that are not critical to our business, because the critical parts of our business, in our case, in digital banking application, critical is to enable people to make different type of payments, domestic payments, SEPA payment, international instant payment. These are all critical user journeys. Or maybe when you go to your banking app to copy an IBAN to share it, that's quite also a critical user journey for us because people do it a lot. All right, but the integration tests we use for minor user journeys, they are 10 times faster than these end-to-end tests, and therefore we employ it. And all the business logic we use, we handle using unit tests because they are the fastest, the cheapest. They can run in a few minutes. Thousands of tests could be executed and evaluated. So back to our test-driven development outside in circle. And to implement invalid IBAN, we also created an acceptance test, but using integration test in this case, not an end-to-end test. Then we came up to a business logic to output the error from our view model. So we extended our view model in baby steps. We created a red test, then made it pass, and another red test, then made it pass and refactored. And at the end, we ran our integration test to make sure that it passes. Important here is that this Detroit school and outside-in test-driven development helps you to come up with tests which are very silent to refactoring. And therefore, we can do aggressive refactoring without caring that tests will break if we really refactor, don't change the implementation details. For example, here the React component is doing too much, I think. Beyond just rendering, it's also take care of the state. So I want to do some refactoring quickly. I will abstract the repository away. So I created a use IBAN hook here with use query in place. And that's actually the code that I just moved from there to there. And now I have an isolated repository functional layer in place. I also could abstract away the hook that does support the journey, actually this internal state of the form, and the usage of repository here, and the usage of the factory function that outputs a model. This I can abstract to, and you see that our view became now also very, very thin. It just does one thing. It renders the HTML output or React output, and it's aware only of its view model. I can also abstract an IBAN input from this setup into some custom React component here. Just a way to make sure my view is super neat and super self-explanatory. It says what it does and knows only about a very limited information, the view model. So we did aggressive refactoring, quickly running end-to-end test, it passes, quickly running integration test, it passes. Of course, our unit test passes. We did some inner code structure changes, but no maintenance was required for the test because tests are resilient. The goal actually is to come up to the test that doesn't bother you when you change the inner structure of your code, but rather bothers you only when a software behavior changes. And these are functional layers that we end up with, a view that only renders, that use case that orchestrates everything for our user journey and provides a model to the view, the repository where we employ React query that interacts with the state of the React app, the adapter that interacts with the network. We build it in isolation completely using a unit test at the beginning, and the service layer that handles all business logic. When application is sliced this way, it's easier to maintain it, to port every functional layer away, to reuse it, and even to replace. For example, if you want to replace global fetch method in your adapter into some Axios, you are fine to just modify this functional layer. If you want to modify the repository layer to replace React query into some MobX, maybe state management in your React application, you will modify just this functional layer. Less things to modify, better, easier to change. And now a few words about zero bugs policy. That doesn't mean you don't have bugs. It just means the type of bugs you will discover will be different. Normally, it will be edge cases, which the team were not able to catch early and implement in a form of or in form of tests. Or these won't be bugs, but enhancements, but people will claim these are bugs. And actually, zero bugs policy means you have a system to ship a software that works. And here is a system that I want to introduce you, a routine that we in my team employ. First, we test drive our development, try to do it together in a form of pair or more programming sessions. We jump to write tests together with test engineer or business analyst sometimes. Then we jump to pair programming session with my peers developers and try to develop this stuff. And we get feedback from all end-to-end tests every morning because they run nightly. We cannot afford them to run every pull request because they take quite long. And here, for example, is an output we get in Slack when the test broke or when the end-to-end tests are okay, so critical user journeys works or not. Whenever they break, like in this case, test case, we prioritize to fix them as soon as possible in the morning. So we investigate why they failed and so forth. And we try to work in a small pull request. I also suggest it to everybody, but frequent pull request, kind of trunk-based Git workflow. You could check online what it is if you don't know. And we run all integration and unit tests on every pull request. So here is an output of our GitHub actions here. Whenever you push a change list as a pull request, and end-to-end unit and integration test will be executed and will not let you know immediately if you broke something else with your code, with your new code or no. Maybe continuous delivering in this setup could be employed. We don't do this. For us, it's just continuous integration in this kind of shape. All right, to end my session with, I wanted to give some benefits of what test-driven development actually brings for me and my team. First, it's quality. So I know what is expected from me to build because I write tests up front. Therefore, I nail down the expectation from a smaller or bigger software behavior up front. Test-driven development helps me to end up with a simple design, separation of concerns. If necessary, since everything is isolated, I can easily make loose coupling by inverting dependencies if I need and want. I end up with a safety net in a form of tests that are resilient to refactoring of inner code structure. This gives me confidence to do inner changes because tests always tell me. Some tests, like end-to-end tests, are living documentation, useful for the whole team, not only for technical people. And I get quick feedback from continuous integration tests that are run on every pull request, so I could quickly fix. And most important, I get a clear metric whether my team delivers quality software or no. And these metrics is not just I think that I deliver something good, but really test says if they are green, then everything is good. You deliver the quality. This gives me confidence shipping React app like with good quality. All right, so I suggest to figure out the desired software behavior beforehand, alone in solo mode or together with your peers, like test driving development with your team by pair programming or more programming. Managers could claim that's not effective, but believe me, I'm practicing the pair and more programming almost for a few years already, and I feel so much benefit for the team and for the quality of the output we produce. Try to set up a system that can allow you to fail early and fix us up because you will be aware where is the brokerage. Know your quality metrics. For me, it's just green test here and there, doesn't broke anything. Ship with confidence on green, and with this setup, with this system, you could live a good life. Don't stress much. Now we know another approach to building software. Keep building on hacks or build well using test-driven development. All right, so my name is Nik, and I'm a big fan of test-driven development, refactoring, and clean code. I build payment systems at Erste Digital. If you want to get better at React development, there are different ways how we can cooperate. For teams at enterprise grade, similar to mine, who wants to learn shipping quality software, I have a workshop. You could reach out to me. Otherwise, almost every day, I post a bite-sized training lesson on LinkedIn. So together we can learn, discuss things in comments. If you want to work with me personally or in my team to practice these extreme programming things like test-driven development, pair programming, and so forth, click on my profile on LinkedIn, and there is work experience section. You will find Erste Digital as a company I work with. Click on their name and you will land to their LinkedIn page, and there is a jobs tab with our current openings. We operate in Central Europe, in Austria, Slovakia, Czech Republic. We work on site and in hybrid mode. If you find that I can bring value to your team, you can invite me to your company to speak at your breakfast or some event you have, or at your conference or podcast, whatever you want. I also offer mentoring opportunities for people who wants to become better. My contacts are available at my website with nik.com. And yeah, that's my story for today. Thank you very much.
Thank you, Nik. It was very interesting. I think I need to do this. So now you can actually see us again. So let's get started on the questions. So the first question that actually came up was, well, could you share the repo so we can follow along? And this one came another time as well. And could you please share the repository at the end of the video? Can you?
Absolutely. Here's a repo. Where's my repo?
Great.
Can I paste it on YouTube?
Yeah, sure.
Perfect.
Can just post it here.
Mm-hmm.
So when we go to the questions, so let's have a look at this one. So sometime we use React context to hold all states used within the app, but end up with a large number of states and difficult to maintain these huge states. What are your suggestions for such scenarios?
Yeah, good question. Actually, React context is fine for React state, for the application state, to manage it, to keep it. But at a certain level, as soon as your application grows, I think using React query or other state managements just super simplifies it. You don't have to care about much boilerplate code and where your data is allocated, because React query manages all. And there are these query keys where you can access the data from any component, for example. So I would say that it depends on your app. If you have a small app, like my example today, then React context would fit in well. Otherwise, whenever you grow, pick some better React state management. And there are multiple: Mobex, Redux, React query.
Okay, great. So then the next question is, shouldn't you use effect with React query, or is it normal to have normal objects in the air when using React?
With React query, you don't need to use effect at all. That React query manages for you automatically. It will automatically execute the API adapter, which you just feed it as a function, and will make sure that it's outputs the data or an error or is pending state when the API is taking time. So that's the beauty of this additional library.
Great, so already answered that. Next one would be, I think Mobex really is good for extracting concerns to adhere separation of concern as much as possible. So what's your perspective on this?
I haven't used MobX before. Redux, yes. React Query, yes. Redux Query too, but MobX, no. I know that it helps with preventing mutation out of your state. So I think I'm not the best to answer the question in regards to this library. Sorry.
Okay. No problem. Then we have a technical question to Nik. When we are using global state management tools, we are dealing with a global variable. When tests are following each other, one test result is affecting one another. One test result is affecting one another. When tests are following each other, one test result is affecting one another. And now comes the second one, sorry. How to deal with this kind of stuff? Do we also have to mock dispatch functions?
No, we have to design our code in such a way that we don't have to mock much. Maximum what we can mock is that I have shown in integration test is a very high level of our interaction with API. So we mock just one functional layer, which is API, but the rest shall work as is, because at the end we want that our test, integration test, for example, assert that everything is wired together correctly. So therefore, mocking shall be, if done at all, then on the highest level possible. But the rest of the application shan't be anyhow mocked, but execute as is the production code.
Yeah, that's good how you described it. And here I also want to add an additional point. This could also be perhaps related to sociable versus solitary unit testing approach. So, for example, here what you illustrated, for example, mocking, minimizing amount of mocking, and mocking, like, when we get to the extreme boundaries, is essentially the sociable unit testing approach, which is also something that I practice as well most of the time, where essentially mocking is minimized, whereas people who may choose to solitary unit testing approach, that's where there's a lot of mocking, but then that's where also there's the problem of test fragility.
So do you have a general guideline when to mock and when not? I mean, you
ideally,
said
don't mock at all, fake.
No.
Yeah, ideally don't mock at all, fake. But as I said, in our experience that we decided that in our case, when we consume around 6 or even more API endpoints for one page, it becomes just overhead to provide so many fakes somewhere at the top of the test, and not only in the top of the test, but also in production code, not fakes, but real implementations. Therefore, we decided, okay, it's easier now to mock the top boundary for API endpoint there and don't overhead with dependency inversion.
Mm-hmm. I have a follow-up question there as well. So is this the case where the page is independently reaching out to 6 API endpoints, that it's aware of the API endpoints, or is it the case where you have an API and then just behind the scenes it is connecting to 6 endpoints and then consolidating?
I got your point. In our case, we are consuming APIs that are also consumed by other devices. For example, bankomats are consuming the same APIs like we consume, the one where you take cash from. The software that is used by bank consultants are using the same APIs for different stuff. And many of our mobile app is using the same API, and so forth. And therefore, there are so many different APIs that we have to put together, and we don't have any BFF backend for front end, this intermediate layer that could aggregate all these and feed the React app only with one endpoint that will provide the whole view models or something like this. Therefore, there are so many complexity on the front end, therefore, for us, because we consume different APIs that other consumers consume too.
Mm-hmm. Great, thanks for that.
I just ask myself, wouldn't it make sense to have an abstraction for all these API calls and then use this abstraction instead? I mean, that you don't have to mock all these API calls, but have like one that accumulates all the data and just gives you the data back and have an interface for that again.
Well, that's a BFF, backend for front-end pattern, what you are talking. Yeah,
in the front end, cool. Basically.
Yeah, that would be cool. That would simplify our single-page application. Yes.
Mm. So you also don't actually create backend for front end in that case. You want to do it in the front end. Or what is the reason that you don't have a BFF? I mean, I'm quite used to BFFs actually.
Yeah, I think the reason at the moment is that it's like from the historical point of view, we grew our app by building a single page and handling everything on the front end, and we hired many front end developers to do this. And then we reached the point that there are already so much complexity. And what we do really, hire more backend developers who will develop for us this BFF layer, or still we can handle this on the front end. And so far we can, with our super core team that provides us infrastructure tooling, we can do this without a problem at the moment. But yeah, it impacts, I would say, our work.
Mm. So in the future, it might change.
It might change.
Great. So we also have another question, a small one. Do you ever test rendering with tools like React testing?
Well, that's a good question. Actually, React testing library is the first one that we evaluated for integration tests. But the output it produces is just a random HTML code inside the console of your terminal. And since we have a design system in place, which we are not aware of, it outputs so much HTML code that it's impossible to understand at which wrong logical branch you ended when your test failed. And we found out that Cypress components testing, or there is another competitor called Playwright from Microsoft, that could visually display for you where you end up in your test. And whenever you end up with some wrong logical branch, you visually see, okay, I end up here. And therefore I can understand quicker where I made the mistake and fix it.
Mm-hmm. So have you tried Playwright also? Or why did you come to the conclusion to use Cypress?
We didn't try Playwright much. I just played myself in some demo projects a bit. Mm. But Cypress came also historical reasons, because we started with end-to-end tests already many years ago. And Cypress was the first on the market that offered, let's say, comfortable end-to-end testing for UI.
No. No.
And now it introduces components testing, and we thought, okay, components testing is actually could be our integration layer, because they are much faster than end-to-end tests.
Yeah. And you're using the same library, which is also a benefit, right? Don't have to have different libraries.
Yeah, the syntax is the same, very easy for test engineers who also maintain some end-to-end tests together. And for everybody, it's very familiar since it's consumed for multiple years already.
Yeah. Okay. Do you guys have some questions?
I think I see a few more other interesting questions that we can show.
Yeah, they came up. Wait a second.
Lots of people
they came up right now, yes.
Yeah.
Okay, so I will start with that one here. So I hope it's a question. I haven't read it yet. Hi, Nick. Thank you for this session. I'm new to TDD. Recently started learning to write unit testing in Jest and React testing library. So I would like to know what resources or what approach should I follow to learn end-to-end and integration test, unit testing, and how should I practice? Perfect question.
Follow me on LinkedIn. Let's team up for mentoring. And together we will come up to grow. Yours and mine will be fun.
I have a question there as well. So, and I must say, your LinkedIn posts are definitely very insightful and even appear on my feed, I think, probably nearly every day. So that's good. Aside from that, let's say if someone is interested in also maybe reading books or tutorials or courses, is there anything, especially combining TDD and like front end, like React or something like that you would recommend?
You know, I'm reading books too and articles, but I'm reading backend books and then project the backend ideas to the front end. I think that's the best. And I could recommend, of course, Test-Driven Development book by Kent Beck. I could recommend Clean Code by Uncle Bob. I could recommend Unit Testing by Vladimir Korikov. These are beautiful books that will help you to understand how to build a super software. And of course, the tips that they provide, even with different syntaxes sometimes, it will fit the front end a lot. Or maybe Refactoring, first book or second book by Martin Fowler. This is a beautiful book too that is applicable for our work. So I don't see that we need to focus on specific React cases and React books. I think the overall software craftsmanship books are the best.
Yeah, and I also see a bit of clean architecture in that way you structured your code. Is that correct?
That's a big topic we could tackle next time, yeah. I'm trying to kind of take ideas from the hexagonal clean architecture and project it to React. But I know that some people on LinkedIn, they do this 100% like by the book. But my team and I didn't feel this 100% match fits and is practical. And therefore, in these regards, my team is violating some concepts from the book about clean architecture and or onion or hexagonal. And we are coupling some stuff together. We allow this ourselves, you know, but still we try to have this separation of concerns and so. But yeah, we could arrange some meetup in the future about this, but not about test-driven development, for example.
Great. Should we still have a... Oh, yeah, we have one here.
A few more questions, I see.
Yeah. So, and what would... I think that refers to a question before. And what about when global state was changed in previous test, and in the current test, we want to check another functionality, but now we have to deal with new global state. So the initial state is changed.
Well, tough question, but I'm aware that in React query, you are not aware of any global state. It is manageable by React query on your own. But you as a consumer of a certain component, you consume just a piece of that state. And if you do this, you could fake it in your integration test, just this state that is necessary for your component at that moment of time. So I think actually global state in React, I think, is a very problematic thing in our industry because many tooling and many concepts are competing with each other. And I believe, and my company also believes, that we shall stick to simpler tools in favor of developer experience. This will simplify testing, this will simplify the development and also management of the state.
Great. So let's have another question, the last one for today. And it also refers to another question, I think. So if I understand, the API endpoints are third-party and not code you control. Is that correct?
Yeah, API endpoints are third parties. The call to the API is a business logic, and this is not what we control. And therefore, we have various options how to overcome this. At the beginning of the session, you remember we designed in isolation the API adapter, making sure that the test doesn't actually interact with the network, because we faked the global fetch method. So every third party, or called side effects in computer science terminology, should be abstracted away and designed in such a way that it's very easy to make sure they are not going away from your application, not going in the network, not going to some external library or whatever. So you could fake them.
Mm. Okay. Any other comments else? I think we have reached the end. So thank you, Nik, once again. I take so much with me from this session, also for my test design and everything, and also this great thinking. Okay, how should I test? What should I test? This is the critical user journey. Everything like that was a very great session. Thank you for that.
I'm glad to be there with you. Thank you very much for inviting, and I hope
thank you.
Developers community get a lesson from that and build software better quality.
Yeah, I hope that too. So if you want to learn how to deliver quality software faster, keep following us, and see you in the next session. Have a nice evening, and bye-bye.
Goodbye.